Good morning, everyone. I'm Mrs. Lulu. I'm the sixth grade teacher at Basin Elementary School in Idaho City. And today we are celebrating Computer Science Education Week, which starts today. We're doing Hour of Code with former NASA astronaut Steve Swanson. This event was set up in partnership with the STEM Action Center. And today we have from the STEM Action Center, Phinia, and from IBL Events, Nick and Kelly, who are our Zoom support. And of course, we have Steve Swanson, our NASA astronaut, here to help us learn how to code. He's going to give a brief background on his experience and how we use computer science, how he used it in his career. So with that, I'll hand it over to Steve. Thank you.
Thank you, Mrs. Lulu. For me, computer science was my way to become an astronaut. I got a job at NASA before becoming an astronaut as an engineer, and I worked on an aircraft called a shuttle training aircraft, which is an airborne simulator of the shuttle. So think, imagine that we're in an airplane that has been modified to fly like the shuttle, but it's all done with computers. And so I got to write software for that aircraft. And then I actually got into the side of flying on the aircraft and flying the aircraft and training astronauts. And that was a great start for me and was fantastic for me launching into the career of being an astronaut. And as an astronaut, I got lucky enough to go on 3 missions, 2 on the space shuttle. They were 2-week missions to the International Space Station to build the space station. And then 1 long duration mission to the space station, launching on a Soyuz rocket, and that lasted for 6 months to basically do science and live aboard the space station. But computer science to me was my stepping stone and something I really enjoyed. Anyway, I mean, I would have been happy not being an astronaut and just doing computer science for the rest of my life. So I was really thankful that I chose that path for me. Are we ready to move on to actually do some computer science? You guys want to? All right. We're going to do a space adventure hour of code program. We're going to do this stuff together, let you know, because I need help on this. All right. So if you look at this, the first level we have to accomplish is pretty easy. It's because we're making this astronaut monkey, and I want no jokes about astronaut monkeys here. All right. Maybe we are or not. I don't know. But let's just have respect for the monkey. All right, so we want to, and he loves bananas. And actually, I do like bananas too, but remember, no jokes, right? Even in space. So we can move up to make the monkey go to the banana. That's the whole idea here, is all we want to do is make it move up to the banana. So I'm going to hit OK. Now, they already started the program for me, the software for me. And I want, if you could do me a favor and count how many ups the monkey astronaut has to go to reach the banana. Does anybody have an answer on that one?
It has to move 4 up.
You were correct, 4. So how many do we have so far on our move up program that we have that they gave us? 3, you're right. So we had to add 1 more. And the way this program works, if I go down to the bottom, you can see my cursor, I can hit move and then up. That gives me 4. Now I go over to the right, and this little green button over here, and I hit run, and I watch it go. There you go. That's pretty simple, all right? So let's do the next level. I know you guys can handle that. All right, now they're gonna have one that you have 2 bananas to go get, right? So we have to figure out how we wanna do that. Let's look at this. So you have 1 that's to the right and 1 to the left. You can choose to go left or right first. Which way would you like to go first? Somebody just speak up and give me a way to go first. I like that. I don't know which way, because you're probably going left and I'm seeing right. So that's kind of, I like that idea. So let's go ahead and we're going to go move left. Now, and I hit return to go to the next line. So I hit my return key. Went to the next line, and then I go, okay, now which way do I want to move? I've already go left one way. Where do I want to go now to get the other banana? Yeah, you want to go the other way. You want to go right. So let's go move right. But now we got to do it more than how many times we need to move right. That's right. We need 2 more. So let's go ahead and do that. Let's see. You think this is going to work? Who thinks it's going to work? Yeah. Let's give it a try. There we go. So what we're going to do one more where I'm going to help you. Then I want the next one is you're going to have to do it all on your own. We're going to do it on your machine. Okay. So as you're doing that work, I want you to tell you about one interesting fact on the space station. You notice how many lines of code we count, how many lines we put in the software. Like we've done 4 lines of software in our code so far, maybe 5 even. On the space station, there are about 3 million lines of code. So think how big that program is that runs the space station and how many people it took to write that software and then to make sure it worked correctly. And that's the hardest part, is making sure it works correctly. Because you can come very, very close, but very, very close doesn't count in software. You have to get it perfect to make it work right. So we're going to do this one together too. So I want you, as I do it on this one, you do it also on your machine, okay? We'll just talk through this one. So this one, there's 2 bananas again, right? We have to figure out how to get to those bananas. So it looks like we're going to have to make almost like a rectangle here. Now, so which way would you like to go first? And you can give me a left, right, whichever way. We'll start with that. Yes, Ellen.
I would say move left first.
All right, let's go left first. So let's do that. Let's move left, turn, left, return. Now what do we need to do?
I was gonna say you could do 3 move rights.
3 rights is perfect. Let's go ahead and do that. All right, let's move down. Does that look good? Let's give it a try. There we go. All right. Now, did you guys all do that too on your own? Have you gotten there yet? All right, you got there, okay? So this next one is going to be a little different. I'm going to explain it, but I want you to do it by yourself, all right? This is called a loop, and a loop just means you're going to do the same thing a certain number of times. That's all it is. So you're going to pick, if you look at this screen, you see up here, it says there's a 6. They call that in computer terms, we don't use the term period. It's just like any kind of software thing. We use dot. So 6 dot times. And so we're going to say that, so for 6 times, we're going to move left. And that's what that does. That's actually too easy. They give that whole thing to you almost, don't they? Is that what that is? Count how many times we have to move left. Oh, that was too easy. I think we need to do this one together and then the next one.
Abby says that it's making the banana move or the monkey move the wrong way. She says we have to move right.
Oh, she is right. Who did that? Who was that smart? Who was that? Taylor? Fantastic. We need to change that. All right, I'm going to do that. So there's 2 ways. I like just to highlight it and then say right. Let's run them. All right, now this one you're going to be on your own. Sorry, I messed that up. But now this is time for you to figure this all out and get to that banana on your own. And then please, though, if you have any questions or something that doesn't seem right, just let us know and we'll try to help you walk through that. Okay? So let's go ahead and do this on your own.
I have a question for you, Steve, while they work on that level.
Sure, go ahead.
What kind of coding language would you typically use when you were working?
Oh, we use many different languages depending on the platform. So when I started out, at NASA, we actually used machine language, which was the actual language of the computer chip itself, which was very difficult to program in. Then we moved on and we went to a language called Ada, which was developed really for the government. And it was based off, Ada was the first programmer, a woman who actually programmed the first computer a long time ago. And so that's why it got that name. And so, but we use that one quite a bit, but I've used from C to Python to C++. I go, part of learning computer science is I've probably done about 10 different languages. But what I find to me is the language is not that important. It's the logic that's important, because your language is just the syntax of what you're trying to say, but it's getting the logic down correct that makes it work right. All right, so who is done? Thanks for the question, Mrs. Lulu. Taylor's done, Alan's done, but Abby's done.
Ryan would like to show what he did on my
Oh,
screen.
that'd be
if that's
great.
all right.
Thanks, Ryan. Let's do that.
And then hit
Oh,
run.
that's good, Ryan. That looks good. Yes. Well
Great, you did?
done.
That's it? Everyone else do it that way?
So now we're on to the next one. So we're right here on this next one. We need to move over here, the astronaut monkey up and do this kind of thing here. But what they're trying to tell us here is that I have not stopped my loop, my 4 times loop. It's going to do whatever I put down here 4 times. I can keep going on and on. If I return, if I write something in here, like just, I'm just going to just do, that's not right, but I'm just going to move it like this. You can see it keeps going down, and now whatever I put in there will stay in that loop. However, if I want to end that loop and I want to start something new, what I have to do is do a delete or move over, and now I start underneath the 4 area right here, and that means my loop is finished. I will no longer be in that loop. And that's how this software does that. Every language that I talked about earlier is actually different. The logic is the same, but it is different. Some languages will actually want you to say, like, end the loop. So you actually type out end loop, and that way you know you are telling the program, I'm stopping it here. The way they're doing that here is just by moving the cursor over with a delete, and you move over. Now, if I want to get back over to add something, I can tab and it'll go back over. So it's a tab or a delete will move it back over. That's the whole idea on this one. That's all I want to say. So go ahead and do this one on your own again. And that's what they're trying to point out on this. And Mrs. Lulu, when somebody has it done and ready, we can share the screen.
I put move up on the last code.
You put a move up. That's exactly right. You put a move up after the 2 move rights. Very good. And did it work right? Have you tried it yet?
Yeah.
All right, good. Does everybody agree with Ryan? Does it work? We got everybody in there? All right, good job. So everybody got that level? All right. You guys are doing great. You're getting this down. One thing I like about software though, because it lets you, it does what you tell it to do and only what you tell it to do. But you have to be very specific about what you want it to do. If you have anything that you say that isn't clear, it will not work the way you want it to. But that's what's the fun part about it. You have to get it just right. If we want to do questions though, we can do that, because you can always do this later on your own and finish it up, because I know you guys have that ability. You've cruised through this so well that I have full confidence that you could do that on your own without any issue at all. While we're doing Q&A, I can share my screen and we can definitely look at some videos, maybe possibly why that goes on. And we can see what, just for some fun stuff that we did in space.
How has STEM helped you in your career as an astronaut?
STEM tremendously. Just to become an astronaut, you have to have a career in STEM. But that can be, you know, from being an engineer to a scientist to a medical doctor, all sorts of ways of doing that. But you have to have STEM in there. That's what NASA requires to that, because you have to be able to understand how these rockets and all the equipment work on board. So that is a necessary thing to be able to do the job and be a good operator or a good astronaut.
What was one of the best things about being an astronaut?
One of the best things about being an astronaut, oh man, that's so tough. 'Cause I mean, going to space is really, really cool. But to me, I think one of the best things for me was actually just being part of the NASA team that is involved in space exploration. I found that I really, really enjoyed just working on this team because, you know, I spent, you know, 28 years at NASA and only got to go on 3 space missions during that time frame, right? But I love my time at NASA because I got to work with people who really cared about our mission, who cared about making it work right and doing the right thing, and was really enthusiastic about everything we did. So I really, really thought that was the best part of it was just being part of the space mission itself and working with people who also felt the same thing.
Were you ever scared while going up to space?
I was scared. Well, you're probably a little maybe scared or apprehensive at launch because that is a lot of fuel you're sitting on. The space shuttle weighs about 4.5 million pounds at launch, and about 4 million pounds of that is fuel. And so that is a lot of fuel you're on. And yeah, everything, you know, thousands of things have to go right for you to make it to space on time. Now, people work very hard to make sure that happens, and it happens most of the time that way. But that's about the time we get a little anxious at that moment, but also happy because we're starting on this great mission. So it's there's good and bad to everything. But that would be the time when I think, at least for me, I felt the most like, I guess, is this the right decision or not? But I knew it ended up being worth it, and it was fantastic.
What does space exploration do to your cells and body?
That's a really good question. And honestly, we're just figuring that all out right now. And a bunch of papers just came out recently, and so I've been trying to read up on them to find out what happened to me. And there's many different things that are going on to the human body. One of the biggest things we have to worry about is bone loss and muscle loss, because when you're floating, your body says, "Oh, well, I don't need to keep making muscle or bone because it's not necessary up here," which is true. But of course, when we come back, we need to have it. So we need to work out 2 hours every day to just try to minimize that loss. Now, there's other things on the cell level that are going on. They just found out that our mitochondria, which are in the cells, and they help like make everything work correctly, start not working as well in space, causing things from immune problems to possible eyesight problems to all sorts of things. And so we're at the point now where we're realizing we have problems. We just don't know exactly how it all works that way, and how to stop it. And that's the big thing, is how to stop it so we can go on farther and not have these issues. But not only does it help astronauts, I also think it helps people on Earth, because the more we understand about the human body, the more we can solve problems about it. And that helps everybody all along the way. So the science on board the space station helps everybody, not even the people on or in space, but those on Earth too.
Was it hard to adjust to being back on Earth after being in space?
Was it hard to adjust? Yes, being back on Earth. Yeah, and definitely after the 6 months one, it took at least 6 months to get back fully. When I landed, I could walk, but not very well. It was very wobbly. And part of that is because your inner ear, which is your balance, right now in your inner ear, it can tell me which way gravity is so I can balance that way. Well, in space, you don't need that anymore, and actually it confuses your brain and causes nausea because you get sick kind of a little bit when you first get to space. So your brain turns off that inner ear because it doesn't help it out at all. And so that way you can do flips and flips all the time in space, and it's no big deal. And but when you come back to Earth, it's really important to get that back. But it takes that was about 10 days for me to get my balance all the way back. And then the other aspect of that is just your muscle strength and coordination. Again, since your body is so much different in space, the way it works, It took about 6 months of rehab to get it strong again and to get everything kind of working smoothly again. And so I spent a lot of time again back at the gym doing rehab and doing everything I could to get myself back into shape again.
Hey, Steve, Mrs. Pimley looks like she has a question that came through chat. What is your most and least favorite meal to eat in space?
And my favorite meal, we'll start with that one, was a chicken and a Thai peanut sauce, which is amazing because most of our food is not that good on space station. It was actually pretty bad, but this was a new one they were trying out, and it actually, to me, like had flavor, it had spice to it, which I like a lot. And so that was really good. There's lots of foods that go into the category of not good in space, but oh man, one that we had was like, I don't know if you guys have ever had grits, but we had grits, and we had grits with butter and grits with cheese. And I don't know who even likes grits, but it was pretty interesting to get that. So that's, we don't get to choose our menu when we spend the 6 months on space. It's a set menu, and that's what you eat. And after 6 months of that, I was really happy to get food back on Earth.
What was the biggest spaceship that you've ever been on?
The biggest spaceship would be the International Space Station, and it's quite large, actually. It's about 360 feet wide, and that's from solar array to solar array, and about 280 feet long. And that's kind of where we live, in that length of 280 feet with different modules that all kind of stack up in a big line, and then some things coming out of that, like tees off of those. And it has the area inside of a large house, like a 6-bedroom large house, or even the volume of a large jet, like a 747 or something like that. So it has a lot of area inside of it. Now it's packed with a lot of things, from science equipment to supplies to all sorts of things, but it is quite a big complex. And right now there are 7 people living on board the space station. I had 6 when I was up there. And it is still quite roomy with that number of people. And so to me, it is a fantastic thing that we have built.
How were they able to launch something that big into space?
That is a really good question. So they didn't launch something that big. We launched it in many small pieces, about 35 different pieces, and we assembled it in space, which is another amazing feat, because these pieces were made in different countries by different companies, all sorts of things, and they all fit together in space on the first try, which to me is another amazing aspect of engineering, how well they could do that. And that was kind of one of my jobs, was that when we went to space, was to put things together. We would bring a piece of the space station up in the cargo bay of the space shuttle, and use a robotic arm to grab it out, move it over to where it needs to go, and then we would go on spacewalks to attach it all up. And that was really fun, but at the same time, it was really amazing to be part of that program and to put this huge thing together that big and make it all work. It was, to me, it's a marvel.
All right, it looks like we're about out of time. I wanted to say thank you so much, Steve, for doing this with us. The students had an awesome experience, and I think they're gonna remember it for their whole life. I know I will. Thank you for your time.
My pleasure, and thank you all. You guys did great today. Thank you very much. You were fantastic. You are on your way to becoming NASA engineers. I really appreciate that.
Can you guys do the little clapping emoji or wave? Thank you so much.
All right. Take care. Bye-bye.